So we're supposed to determine if f of x, and which is blue here, and g of x are inverses of each other. So just quick note, they're not functions, right? It fails the vertical line test. There's two outputs for x equals 6, for at least for the red relation. The blue relation, that looks like a function. That's not something we have to answer though. What you want to look for with a graph of two relations, like two curves, is you want to look to see if they're mirror images about the y equals x line, which is this orange dot here. Because if they are, then that means the range and the domain have been swapped between the two. The x's and the y's have switched places about the identity function. So like I look for key points. They both cross at the same spot here. That's good. They need to. This point 1, 3, x equals 1 and y equals 3. There's a corresponding point y equals 3, x equals 1, so that's good. And let's check this other point 8, 5 if I can. I don't know. I can't. Well, let me move it. It looks like if red has 8, 5, then blue needs to have 5, 8. If you go to 5, go up to 8, looks like it's going to happen. And then again, they cross at the same spot. It looks like they are inverses. And, you know, with a graph, you can never be exactly sure. Maybe they're off by a decimal, but that's the best we can do. You know. So determine if these functions are inverse of one another. Let me pull this up on the whiteboard. This is an old question. Come on, computer. You can do it. There we go. Okay, so to determine if two functions are inverses of one another, plug one of the other functions into the first function or vice versa. Just plug one into the other. So this notation says that I'm putting g of x in for all the x values of the function f. So I'm writing down the function f, -2. Oh, I got to an x. I need to replace that with what g is. So I've replaced x. And then if you distribute that -2, -2 times -x over 2, that makes x. -2 times -2 makes +4. And then we're subtracting a 4. There, the identity function, y equals x. If it comes out to be just x when you plug them into each other, then they are inverses of each other. This question asks us to find the inverse of this function. So what you can do is you can replace the f of x with a y, just give it a little variable, then switch the places of x and y, because that's what an inverse is. The x and the y have been switched. The domain and the range have been switched in an inverse function. So now we just have to get y by itself again, and we'll have inverse notation. We'll have an inverse function. So I'm still trying to get y by itself. I'm going to divide everything by -9. We could just write it like this. Y equals this x plus 6 divided by -9. And the function notation would be that it's kind of bad notation to me, because like a new student thinks that's f to the -1st power, but that's not it. That's inverse notation. The inverse is x plus 6 over -9.